this is our next case study. 0 power n, where n is a prime number. So which means if you look at the language, it consists of 0 power 3. I am not considering 2. So 0 power 3, 0 power 5, 0 power 7 and so on. Now we want to show that this one is not regular. Remember 0 power n, where n greater than or equal to 1 is regular. But the moment you have a constraint saying 0 power n where n is a prime, 0 power n such that, for example, we say 0 power n where n is prime, or we say 0 power n where n equals m square for m greater than or equal to 1, meaning n is a perfect square, or n is equal to m factorial for some m. So when you start asking some constraints on m, or in addition to being 0 power n, it should also satisfy some property with respect to n. And it turns out that when we bring additional property like this, it is non-regular. Okay. So this is quite different from whatever we have seen so far, because it involves computation, checking whether a number is a prime or not, and a perfect square, factorial, and so on. Let's do the following. We have to choose a string w, and whose length depends on n. So the length of this string is n. So condition is satisfied. W must be at least n. So we have control over w and I. Decomposition we do not. So now the decomposition part, however way we decompose, we find a string which is not part of this. Okay, so we need to come up with a decomposition. So let me say v is some number of zeros and u is some number of zeros. So this is my u and this is my v, and v alone we know it is at least 1. U may exist or you may not exist, and followed by z, and again z also may exist or may not exist. So having given these two, and this would be n minus this. Okay, and this is all we have. So decomposition could be for all u, for all v, for all z, such that v is at least 1 and uv is at most n, because w itself is a string of length n, and naturally you will find only zeros, and u may exist, may not, similarly z. Okay, now what is that we want to show? We want to show that if you look at the string, now we want to show that there exists one I with respect to this w prime is not part of L. So let me rewrite this part. So it is 0 power r and 0 power k times 0 power k to the power I minus 1, 0 power n minus r minus k. I am retaining one copy of 0 power k and moving I minus 1 copies aside. Okay, now this becomes r, k, and this part, this gives you 0 power n times 0 power k times I minus 1. Okay, so now with this you get 0 power n plus k times I minus 1. So now we need to choose one I carefully, such that with respect to this I, we get a string which is not part of the language. what we will do, and what should be the idea when we say we obtain a string W prime which is not part of L, which means such a string must be a composite number. The length of the string must be a composite number because the language contains all prime numbers. So naturally I need to choose one I such that when we simplify this, I should get a composite number, which means 0 power composite number is not part of the language. Okay, that's the overall approach. So which means this somehow I should write in product terms so that I can argue easily that that's a composite number. So what I will do, involving n and k, let me choose I to be n plus 1. I could be any integer, and it says there exists I. So the choice of W, choice of I is with the person who is actually proving the argument. Now with this you can see that we can come up with, so the choice of W and choice of I is with the user. I choose this carefully so that on simplification this becomes a composite number. Now you substitute this, we get 0 power n plus k times I is n plus 1, so this becomes n. So on simplification we get n into k plus 1. This is what I was referring to before. I want to substitute an appropriate value for I so that this becomes a product term. One can argue that it's a composite number. Now look at this term. This term, and k is at least 1, so which means k plus 1 is at least 2. And n is, if you include 2 then it is at least 2, but I start from 3, so n is at least 3. So clearly neither of n or k plus 1 is 1. So n is not 1, k plus 1 is not 1. And most importantly, this expression is divisible by n. This is also divisible by k plus 1, which means this one is a composite number. So one has to argue that it is a composite number, and also that you get to see that this one is not 1 and this one is not 1, and this expression is divisible by n as well as k plus 1. Therefore it's a composite number. Since it's a composite number, W prime equals 0 to the power n, this is not part of L. So that shows that here is W, here is I, for which we have produced a string which is not part of L, and therefore you can conclude that L is non-regular. This implies that L is non-regular. Fine.